Good morning, everyone. Let's discuss trigonometric identities. We wrote like a lot of trigonometric identities that we've learned and we proved them in like previous sessions. So let's write some of them now. Let's write some of them together. Okay. Okay. Let's write some of them. Something like Pythagorean identity. We said that cosine square an angle plus sine square an angle equals 1. Then when we divided the whole equation by cosine squared, so it's going to be 1 plus tan squared theta equals secant squared theta after dividing the whole equation by sine and cosine, cosine first. If I want to divide it by sine squared, so cosine over sine, which is cotan squared theta plus 1 equals 1 over sine, which is here cosecant. We said also for even odd functions, we said the one that will give negative sign is what? Cosine and its reciprocal. So cosine negative x equals cosine x. Okay, so equals here cosine x. So this is the only function that will give negative sign and its reciprocal cs. So which is here secant negative x equals here secant x, which is the positive one. Also, we prove them graphically. Also, we prove that in another session, we proved that cosine an angle, so let's call it alpha or even a, call it whatever you want, alpha plus beta equals here, equals cosine friends together, so cosine alpha, cosine beta, so here friends together. Here I have plus, so here it's going to be minus sine alpha sine beta. Also we said here that if I have minus, so that means it's going to be here positive. Okay, so if I have here minus, this one will be positive. Also we said using co-functions identities, if you still remember, co-functions identities. If I have here cosine an angle, so cosine y over 2 minus an angle, let's say it's theta. So this is any angle, an angle. So whatever here, so it's going to be sine this angle, sine this angle. If I have sine pi over 2 minus theta, so this is an angle, doesn't matter what's the name, so it's going to be cosine theta. Let me change the name now. For example, if I have tan pi over 2 minus, let's say, b, so it's going to be cotan b. Excellent. If I change this cotan pi over 2, sorry, this is st, cotan pi over 2, let's say minus a, so it's going to be tan, tan a. So whatever the name of the angle here, it's going to be directly there. Also the same thing for secant and cosecant. Secant here is pi over 2 minus, let's say, b, so it's going to be cosecant b, and cosecant will be, pay attention, it's pi over 2 first minus the angle, let's say this one, so it's going to be secant a. Clear? Up to this moment we didn't prove sine sum, okay, sine sum formula, okay, sine sum formula. How can I prove it using those information that we've learned or using my knowledge? What is sine? Basically, first of all, we give it to you as sine. Let's say alpha plus beta or a plus b, it's fine. So I'm going to call it now a plus b or even alpha plus beta equals here. It's not spoiled as cosine, so it's going to be here sine a cosine b. Here I have, sorry, here I have plus, so it's going to be plus also, plus cosine alpha, or let's say here this is a, so cosine a sine a sine b. Okay, this is the formula. So how can I use my knowledge here that I've learned to prove this one? Let's start together. Let's see how. Okay, can we use our knowledge, because already we proved in one full video like how did we prove this cosine? Already we proved it. That means it's applicable for all. So how can I use cosine to prove sine? Excellent. Excellent. So we are going to use this one, the blue one. All right. So how are you going to apply it? So I'm going to say here cosine pi over 2 minus, I want this one, okay, minus, let's say here A plus B. This is my name of angle, okay, this is the name of the angle. My name, it's fine, I don't care. So this, based on our rule here, is going to be sine this angle. What is this angle? It's A plus B, right or wrong? So brilliant. Can we start from this left side and end up to this side? Yes. So let's start from this left side. So here what do I have? I have here cosine. I'm going to enter here this negative sign. So pi over 2 minus A minus B, right? I will take the first two together using associative property, can I? It's fine, as long as I'm still in my room. So the rule says what? This is the first angle, okay, well, this is the second angle. So cosines and friends together. So it's going to be cosine pi over 2 minus A times cosine B. Am I right? Plus. Plus or minus? Plus, exact. Because here I have minus. Huh? So between them is going to be positive. So positive here. So anyway, it's my pointer. Yes, so it's going to be sine pi over 2 minus A cosine B. Sorry, sine. So they're both together, okay? Friends together. So sine B. Okay, also using the same cofunctions. What do I have? Here I have cosine pi over 2 minus A. So if I have cosine, it's going to be what? Sine, based on the rule, huh? Sine A, sine the angle. Cosine B is as it is, plus sine pi over 2 minus theta minus an angle equals the same angle. So it's going to be here sine, sorry, it's sine, so it's going to be cosine. It's sine, so it's going to be cosine. Cosine what? Cosine A. Sine, what is this? It's basically this one, right? So this is now what? This is sine A plus B, which is sine A sine A cosine B plus cosine A sine B, which is our requirement. So now we proved the sine sum formula. Okay, now let's prove together the sine difference formula. Okay, now let's prove the sine difference formula. Prove the last one. Prove the sine difference formula. Okay, so what's sine difference formula? It's sine. Let me use now alpha. Sorry, I want just to show it. Doesn't matter what are the names. Sine alpha minus beta equals sine alpha cosine beta. This is minus, so this one also will be minus. Minus cosine alpha sine beta. Okay. So how we are going to prove this one? Simply, we have here sine. Let's start from the left side. Sine here alpha minus beta. Why did I use this one? Because already we proved it. So sorry, here this I want just write here line plus. Okay, I want just negative to be in sign. Okay, just to keep the balance. Okay, which is basically, let me just rewrite it here. I want just to show you something. Yes, I want to show you here that sine alpha minus beta. I'm gonna start again from the left side. Left side. What is left side? Left side says sine alpha minus beta. We just proved just right now in the previous slide the sum. So how can I apply sum here? Sine alpha plus minus beta. Can I do this? Why not? But this is now the first angle. Okay, this is first angle, and now this is second angle. Okay, so the rule says what? Already we applied it. The rule says sine first, which is sine alpha, cosine second, which is negative beta. This is sine, so between them I have plus. Between them I have plus. Plus what? Cosine alpha, sine, negative beta. Which one will gulp negative sign as we proved at the beginning or reminded you? Cosine. Excellent. So this one will be sine alpha, cosine beta. And this negative we will keep it, so it's going to be minus cosine alpha, sine beta, which is the requirement. Excellent. Which is here we started. This is from that, or we reach it to the right side. What do you think if I have tan? How we are going to prove it? Let me give you a hint. Tan formula. Okay, this one is going to be like practice for tan sum formula, tan difference formula. So tan sum formula. Okay, tan sum formula. The rule says tan alpha plus beta equals tan alpha plus tan beta over 1 minus tan alpha tan beta. Okay, again, we are going to start the same story. We are going to start from left side. We have to reach to the right side. So it's going to be like this. What is tan alpha plus beta? Tan alpha plus beta. It's sine alpha plus beta over cosine alpha plus beta. Right? Continue here. What is sine? It's sine alpha cosine beta plus cosine alpha sine beta over cosine alpha cosine beta minus sine alpha sine beta. Okay, so we are going to divide the whole equation by what? By sine. Here I have here sine, so I want to remove cosine. So what do you think? I want here sine over, because my eyes here, so what do I have to keep? I have here sine, so I need cosine, right? I need cosine alpha down, and I want to remove cosine beta, so I have here cosine beta. So now I'm gonna remove it. Can I apply the same thing there? See, let's see. Here I have cosine alpha, cosine beta, right? So see, cosine alpha is again with this one. Still for me only tan beta. Excellent. Do the same thing down, because you've done something up to keep the balance. You have to do it again down. So cosine alpha, cosine beta, we said, right? And here cosine alpha, cosine beta. Yes, finalize your answer, please. Cosine and cosine has gone. Cosine alpha has gone. Cosine alpha gone. Cosine beta has gone. So it's going to be simply sine alpha, right, over cosine alpha plus sine alpha beta over cosine beta over 1, because here I cancelled all, and sine alpha, which is minus here, sine alpha, which is sine alpha over cosine alpha times sine beta over cosine beta equals what? Sine alpha, which is here tan alpha plus tan beta over 1 minus tan alpha tan beta, which is actually the right side. Do the same thing for negative side, or you can just take it as you can just take it as tan alpha minus plus or plus minus beta. I mean like this. So it's gonna be easy for you here to prove it. I'm gonna leave it as a homework for you or as an extra practice for you. I mean here tan alpha minus beta. What is this? It's tan alpha plus minus beta. You have like different ways now to prove this. So you can choose whatever you prefer and apply that. Okay, I hope it's clear for you. But how can we prove all of those rules to evaluate the exact value of sine like non-common angle? Something like what? Let's once again. Let's say that I want to evaluate or find the exact value. So here I want the exact or evaluate exact value of what? Of let's say sine 75. Also, I want another example, something like tan 15. Okay, tan 15. Or even you can just write 15 honestly as pi over 12. Okay, pi over 12. Using this one that way, it's fine. Okay, so here, if you want to just apply, I'm gonna think about this is but none of the common angles. So based on the unit circles that you've learned that there's 0, 30, 45, right? 60 and 90, right? So I want 75. I'm gonna ask myself, what is 75 basically? 75 means what? What and what? Plus 75 degrees. So it's what? Do you think that this is 45 plus 30? Yes, excellent. 45 plus 30. Do you have any other option? You can do another option if you want, so it's fine, the same idea. But here I think it's easier to use this one, okay? So use one of the common angles to create the given angle. This is the first step. So we've known that sine 75 equals sine. What is sine 75? It's 45 plus 30. So this is the first angle, second angle. So this is first, but this is second angle. So sine here will be what? Sine 45 cosine 30 plus, we are applying the rule. The rule says sine first, cosine second. Cosine first, sine second. Okay, again use the same thing. Here I have my fingers. So this is my finger. Okay. Again here, I'm gonna just draw my fingers as we've drawn this together. This is second finger. This is your left hand. Okay. Those are fingers for the left hand. Yes. Sine 45, it's radical. Sine 45, it's radical 2 over 2. Sine cosine 30. So cosine 30 here, this is 30. How many fingers up? Radical 3 over 2 plus cosine 45 here. How many fingers up? I have radical 2 over 2 times sine 30. Where is 30 here? How many fingers down? It's only 1, so it's half. Finalize your answer. Radical 2 times radical 3, it's radical 6. Okay, over 2 times 2, which is 4, plus radical 2 over 4. You can just write it over one fraction, I'm sorry, over one denominator, over here 4. Now you found like the accurate answer for this one. Okay, let's move on and let's find like discuss the last example. Here I have pi over 12. What is pi over 12? It's 180 divided by 12, which is basically what? If you want to divide here and there, so this one 2 by 2, this is 90 over 9, and this is by 2, it's going to be 6. What is 9 over 6? It's going to be 9 or 9 over 6, if you just divide, it's going to be 50. It's going to be what? 50. Because it's over 3, it's going to be like 30. With 30 divided again by 2, so it's going to be 50. So you can keep it like this, or you can just like, what is this? It's 10, 50. Again, ask yourself using the same unit circle, what are the common angles? We have 0, 30, 45 again, right? 60, and finally 90. Okay, so how we are going to apply? Ask yourself, what is 15? It's 45 minus 30. Or maybe your friend is gonna say, but we can also create it using this way. It's 60 minus 45. Either this or that way, both of them will reach the same answer. Okay, so I'm gonna use this one. If you want to use like the radian formula, so it's fine. So I'm gonna write here 10 by over 12. What is 45? It's 10. 45 here, it's pi over 4 example. Minus 30, which is pi over 30 here, it's 6. Okay. Okay, the rule says what? This is first angle, this is second. Second, okay? Yeah. Apply now. The rule says 10 pi over 4, which is 45, minus 10 pi over 6, which is 30, over 1 plus 10 pi over 4 times 10 pi over 6. Apply the rule, or finalize, I mean. 10 pi over 4, which is 1. This is pi over 4. How many fingers down? So I'm going to just draw those are my fingers, okay? So how many fingers down? Radical 2 over radical 2, which is 1. Minus 10 pi over 6, which is here, this one. 30. So here I have sine over cosine, so radical 1 over radical 3, radical 1 over radical 3. So here I have to rationalize, so radical 3 up and down. So it's going to be radical 3 over 3. Okay, over here 1 minus 1 times radical 3 over 3. I mean here there's positive between them. Okay, just finalize, so I'm going to make same denominator. Here I will multiply by 3 up and down. Also here we are going to multiply by 3 up and down. Okay, oh sorry, I mean here, I mean also we are going to make same denominator. So this is 1, so we multiply here up and down by 3, here also up and down by 3. So it's going to be 3 minus radical 3 over 3 over 3 plus radical 3 over 3. Keep change flip, it will be 3 minus radical 3 over 3 plus radical 3, which is my answer. I hope it's clear for you. Have a nice day. Thank you for watching. If you have any question, you can leave it in the comments.